Okay, before we get into the very last lesson, you need to make sure that this table is all filled in. This table is also in your book. It should be in 9-6, but for this year you need to make sure that you have the alternating series test. The next term needs to be less than the previous term, so decreasing, and the limit has to equal 0. And then the alternating series test also is the partial sum with the error bound, meaning the actual sum minus the partial sum must be less than the next term. And then we have in here the ratio and root tests if you haven't written those down. So pause, make sure that this is all filled in, and this needs to be memorized. It's a lot of information, but we've been memorizing it as we go. So you should be ready to answer any of these questions and how to use the test and how to know if they converge or diverge. All right, so to finish this 9-6 is we're doing a little review, big review of all the tests. So using general guidelines to determine which test would work best for a given series. Like, how do you know where to start without the question telling you? Find the best test to use to determine convergence or divergence can save a lot of time and stress. The following guidelines can be used to help quickly find a good test to use, but you have to memorize all these in order to use them, so I don't know. Okay. Does the nth term test for divergence approach something other than 0? If so, that diverges. Usually you can do that in your head, you guys. You could just say, as n goes to infinity, is it going to something other than 0? If it does, then it diverges. The easy special types would be geometric or p-series, and then telescoping is where you have a positive and then negative, and they cancel each other out. If the series is alternating, then you need to use the alternating series test. If it's closely related to a geometric or a p-series or an alternating series, then we use the direct or limit comparison. Are the terms raised to the nth power? Then we use the root test. Okay, can it be easily integrated? Then you would use the integral. If nothing else works, use the ratio test. All right, determine which test to use. Let's see. Dumb lights, sorry to call him dumb. All right, ready? Get set. I have a question on the very first one. Hold on. Okay, sorry. So quickly, what is the limit of this as n goes to infinity? Isn't this same over same, which gives us 1/3? So if it doesn't equal 0, then this diverges. So you can see that right away, and that's called the nth term test. All we're doing is determining which test to use. All right, do you see how this is a fraction raised to a power? So what's that going to be? That's going to be a geometric. And pi over 6 would be r. Okay, easily integratable. Can you see how you can say u equals negative n squared, so du equals negative 2n, and that's there. So if it kind of looks like something that we've integrated in the past, then you're going to use the integral test. All right, this one, it's not a geometric. We could integrate it, so you could use the integral. It does closely relate to 1 over n, which is the harmonic series. So you can try the limit comparison test on this one, or the integral, actually. There's more than one right answer. Okay, which one's this? What does this tell you? This is an alternating series test. Alternating series. All right. What about that n factorial over 10 to the n? Which one did we use for factorials and n's? That's called the ratio. Now, what if we have a power of n? Power of n is the root. 1 over n squared. Well, is that geometric or p-series? That's p-series. The power of n is geometric. Oh, what do we have here? Power of n, geometric, 2x over x squared, isn't this easily integratable? You can let u equal x squared and then du would be 2x. So we're going to use the integral test. What about this? This is weird. Let me look at another weird one. We did this, we did limit comparison. Doesn't this closely resemble 1 over n squared? So let's do direct comparison. How do you know to use direct or limit? That's a good question. Look it up in your notes. Look it up in your notes or try both. Okay, it's not always going to be the same. Same over same. Same over same means the limit of this is 3 over 1, and 3 over 1 does not equal 0. So that is the nth term test. Nth term test. Okay, super easy when someone else is doing it, right? I'm just telling you what it is, but you should be able to get a feeling. Some are going to be harder than others, and that's okay, but just try and get the easy ones: p-series, geometric, ratio, root, okay, the nth term test, all right. The comparison ones are, for me, kind of the harder ones because there's 3 different kinds, and it's like, wait a minute, which one do we use? And then the integral test. I love calculus, but I don't really like doing integrals in my serious questions, personally speaking. All right, you're going to practice this. Okay, it shouldn't take too long. 53 through 67 odds. Use calcchat.com. You guys use that to see the answers. On the back of this paper is going to be the 9.5, 9.6 quiz review, but we actually won't have a quiz on this. But remember, the Chapter 9 test review is made up of all of these questions from the quiz review. Okay, we got a lot going on, a lot of assignments, a lot of mathy math. Answers to this. So glad you're watching because I don't think I would show this. So pause and copy the answers down somewhere. All right. And check the board, check Google Classroom to make sure that you know what all the assignments due are. Thank you very much.